I chose to go to CppCon because there's plenty of opportunities to both have a lot of fun and network. You can come here to just learn and study, and there's a great community behind it.
All right, I guess it's time to get started here. Mic working? Everyone can hear me? Awesome. First off, thanks for coming to the talk. Everybody excited to hear about some CMake stuff? Yeah. All right, let's get going here. All right, first a little short about me. I've got a short, boring list of jobs. I worked 9 years at GE Research in a computer vision group. My task there was, as a recent bachelor's graduate, was moving them from symbolic list machines to this shiny new C++ language using Cfront on Solaris pizza box workstations, later Linux and Windows. I kind of became the software library guy doing, CMake and auto tools. I left GE in 1999, 1998, we started Kitware. I'm one of the founders and the CTO. CMake's prototype CMake kind of got started in 1999. Mostly management now, sort of pointy-haired boss stuff. I'm looking around to find funding for CMake to keep great people like Vito happy and working. And along the way, in my early 40s, I picked up ultra running. That's a picture of me running Leadville 100 race. That is down power line.
Been there.
Awesome. We'll have to talk after.
On wheels, though.
All right. What's a kitware and what does it do? You might be asking yourself that. Well, hey, we collect $100 from everyone that uses CMake on our CMake subscription model, right? Everybody's here, you're paid up, right? How many people are using CMake? Yeah, and you're all paid up. Awesome. So let's go to ChatGPT as we do these days. And hey, how much money would I get if I get $100 for every CMake user? Well, it does some figuring and stuff, and figures there's roughly between 1 million and maybe 10 million CMake users. So that's $100 million to $1 billion a year. That's pretty cool. So what does Kitware do with this $100 million, $1 billion of CMake revenue? Well, we could have 500 like rock stars, 1,000 average developers. We're right in the middle there, about 1,000 developers. Plus, I'd have my yacht and private jet, and one of these fancy, ridiculously expensive cars. And what would these 1,000 CMake developers do at Kitware? Well, they would develop any feature the users wanted. They would fix any issue reported within 24 hours. They would write perfect documentation and provide support to any question asked. All right, well, Kitware actually doesn't do that. And I'm happy that CMake's open source. And I love the open source community. And actually what Kitware does is consulting and research contracts in areas of expertise of computer vision, data analytics, scientific computing, medical imaging, and software solutions. And we build this on open source platforms. And the Kitware Software Solutions team, which is the CMake-ish team, they do more than just CMake, but it's a small team in a smallish company. Where did CMake come from? Some of you may have seen this before, but for those that haven't, Kitware was the lead engineer team for the Insight Segmentation Registration Toolkit, which was created by the National Library of Medicine. They had a project, the Visible Human Project, where they created a data set that had CT, MR, and then the bodies were donated to science, and they froze them solid and sliced them as soon as they could and took pictures. So they had this data set that would help advance science in medical imaging. But they realized that they needed, because the language of science really is programming languages these days, they needed to codify the state of the art in segmentation and registration. So they wanted to create a toolkit. Kitware was known for creating VTK. We got brought in for that. And then I immediately went off script on the statement of work and created a build system for ITK. And the rest of you in this room. Since then, CMake's had funding from various projects, outside contributions, and anywhere we can shake the trees for work. So in doing this talk, I found this blog that I posted in 2015, which pointed out that we just had a CMake birthday, August 31st of 2000. 25 years. Yikes, I was only 33. One of the main objectives was to not have external dependencies. This is why it had its own language and was all just dependent on C++ compiler. And back then I wrote, it was avoid what I call the Easter egg hunt of build process. I got to get this, and I got that, and then I built this. And that was harder and harder the further you go back in time. Still not solved today. So let's click on that first email. This is the announcement of CMake to the ITK mailing list. I've reworked the build process in ITK. I've created a package called CMake, cross-platform make. It includes all the build process for building CMake in there. And down here you can see I've changed a few things. PC Builder is now called CMake Setup, and makefile.in, those are all called CMake list.txt. So this was sort of the birth of CMake and CMake list.txt. So the arrows of CMake, I encourage you to go watch this talk that Vito, sitting right here in the front row, gave at C++ Now on postmodern CMake. And he broke it down into the CMake errors of CMake 1, 2, 3, and 4. So CMake 1, the primordial flag soup. I kind of refer to this as the friends and family error. So there was ITK, VTK, ParaView, maybe a few more projects here and there, but basically pretty close to home. Get a bunch of compiler flags and pass them down the source tree and try to get things to all link. And it worked. It looked something like this. You could create source lists and then add them to executables. Curiously enough, 25 years later, when CMake 4 just came out, this was finally deprecated, and has caused some people trouble. So this is basically using a file without its extensions. And CMake used to go searching. If it couldn't find the file, it would look for .cxx, .capital C, .little c, whatever. But also, as Vito pointed out, find package was part of CMake 1.0. So we had good thoughts. Didn't necessarily execute on all of them. And if I'm stealing slides from Vito, they're going to have the little Vito in the corner there. CMake 2, the world domination error, was basically me fishing for projects to use CMake. Eventually, I landed the big one, which was KDE. It was kind of funny how it happened. There was a developer, and he missed going to Academy, and he was saying, I think we can get CMake as a build system for KDE. He missed the conference, and he sent me an email, sorry, man, I wasn't there. I was sick or something, and they picked scons. And I was like, oh well, you win some, you lose some. Well, I'll keep fishing. And 6 months later, he sent me an email and said, hey, Bill, I think we have another chance. Look at this email. So on their developer list, they were like, it's been 6 months and we can't still build anything. What's going on here? So I was like, all hands on deck at Kitware, which back then was like 10 people. Let's get KDE building on as fast as we can. I think we turned it around in a couple weeks and we got the core library working. And then a week after that, someone else got it working on the Mac. And then they were running KDE apps on the Mac, which no one had ever done before. And then a few weeks later, someone had stuff popping up on Windows. It was kind of really rapid. And KDE has this motto that he who codes wins. So they ditched scons, which then that branch of scons became WAF, I think. Anyways, so this was huge for CMake, and it brought a lot to the project. So it forced us to be very conformant to Linux installation things like shared library versioning, et cetera. It also solved a little bit of the chicken and the egg problem because CMake was now part of Linux distributions because they needed to build KDE, so it was pre-installed. And it also ended up birthing modern CMake. Also to note, in 2008, LLVM put their first CMake file in. They had a dual build system for quite a while. This chart over here is Google searches of AutoTools versus CMake. And that inflection point where it just shoots up is when KDE adopted CMake. The rest of you people in the room were like, what's this CMake thing? Why is KDE using it? And Stephen Kelly worked at KDAB at the time and a KDE developer. Coined the term modern CMake. He's got a great blog on it if you want to Google search that. And I pulled out one line from the blog that this simple example of Qt shows the essence of modern CMake. We're fine packaged Qt widgets, and then target link libraries, my application, Qt5: widgets. And this is showing that complete target model that we see so popular today and very useful in that Qt5 widgets was built somewhere else and I'm just pulling it in and it looks just like it was built locally. I'm not passing around linker flags or -L things that I pulled out of who knows where. I'm actually getting an object that's a target. So yeah, CMake 3, another slide from Vito. I hope you like target star commands. And this really gets the usage requirements and build requirements. So some other random things that I felt I'd like to share that I think are really cool in CMake that maybe some people don't know about or don't know how to use. Did you know how many people knew you could do performance testing of CMake itself? How many people would like to know why their CMake's running slow? Yeah, see? Okay, so maybe you'll get something useful out of this. So essentially, in this simple example, I went into VTK and I just added an execute process command sleep 10. And then when I ran CMake, I said, hey, I want profiling format Google Trace, and I want to output it to a CMake profile.json. And you can try this in your CMake project. It works really well. It's really easy. And then you go to Perfidio, and you load up that data file. And you can see that now my configure time, half of it is spent in execute process. And even better, I can see that the arguments to that are command sleep 10, which is obviously the source of my problem. And if I just delete it and then run it again, we're going to see that the configure time shrinks by 10, and we get a nice output. But obviously, you drill in, and this is amazingly useful. Like if you're having times with configure, you can figure out, because someone might have done something really weird, and it's calling execute process over and over again, or some other problem that it's doing. And it can also go into the generate phase. So if you kind of set up some system that forces CMake to do a whole bunch of work at the generate phase, you'd be able to see it here as well. Debugging CMake. CMake actually supports the debug adapter protocol, DAB. So any editor that supports DAB can debug CMake code. This is a VS Code showing on the right. You can set breakpoints. You can see call stacks. It shows you all the cache variables, which is a surprising number of them. I think this is just doing CMake itself. And it's, no, this is VTK, I think. Yeah, 512 cache variables. So. And directories, so basically a full debugger for CMake. How many people have used CMake debugger? Okay, cool. How many people just learned there was a CMake debugger? Awesome. That's great. I'm not wasting my time up here. I worry that I'm just like telling people stuff they know. But I suspected that they didn't. All right, another interesting feature I think that was really cool that was added to CMake somewhat recently is parallel install. It's not on by default because it could cause problems in some systems if you've set up your install to have weird dependencies. But if you haven't, you can set this global property to turn it on, and then you can do CMake -- install -j, some number of variables. And this can, if you have a really large project that installs a lot of files, you can speed it up quite a bit. And I'll get to where this visualization on the right is coming from here. But there's actually a way to visualize the install step as well in CMake. But before we move on to CMake 4, please indulge me as we go in the Wayback Machine. And we're going to look at CMake's webpage. The earliest one I could find was 2002. So I guess it took us a couple years to get a web page. They were harder to do back then. But welcome to CMake, the cross-platform open source make system. It's used to control the software process. This was kind of interesting that I had some goals here, and I'll get to that a little bit later. Side note, in 2002, we had C++98. And the big new things were namespaces, bool, RTTI, new style casts, exception handling, and the STL. No reflection yet. Click on About. It's this, talks about it. Interestingly enough, back then it was make files on Unix and Windows MFC files for Windows. The origins of CMake goes into where it came from. Here's an interesting note, sort of the curse of software that developers are always much more proficient at writing code than documentation. And here we are apologizing on our webpage that the pace of development has outstripped the pace of documentation. As a result, the best way to learn about CMake is to study existing CMake stuff and copy it. So this will come back to bite us, and I'll talk about this throughout the talk a little bit. It's actually review season at Kitware, where we do our employee reviews, and a lot of that is reflecting on goals and see how we did. So let's take a look at these goals that were on the original CMake page. So develop an open source cross-platform tool to manage the build process. You want a standard build system? You've got one. It's called CMake. This is Resistance is Futile. This is Bryce Adelson, C++ Now in July 2021. So I give us an A++ on creating an open source cross-platform tool. Okay, allow the use of native compilers and systems. Originally it was just make files. It's been a lot of other stuff. Visual Studio, Xcode, Ninja was a really cool one. And I think this is one of the more powerful features of buying into the CMake ecosystem. Prior to, Ninja got released by Google. And then I think within a month or so, we had it in CMake. And suddenly anybody that bought into the CMake ecosystem, their builds got suddenly faster, right? Like overnight, because this new build tool was now available to them. And that was one of the goals of CMake, and that's why it used the native build tools and wasn't a build tool itself, because there is a rich ecosystem out there and people are developing new tools and new things. But with CMake, we can bring those tools to the developers, and the developers don't have to go to those tools or do any port to get to them. And then there's something new I'll talk about. And then pretty much every compiler under the sun, and some that we probably shouldn't even be supporting anymore, but we still are because we like that, So I'll give us an A++ on supporting native compilers and systems. Anybody if you disagree with my grades, raise your hand. If you want to give me an F, I'll take it. Simplifying the build process. All right, this one we probably didn't do quite as well. So if you look at the C++ Developer Survey Lite from 2024, you can see that people are complaining about managing my libraries and applications that they depend on, managing my CMake projects, is a major pain for 30%, a minor pain for 38%. So something like, almost 70% of the people are like, damn, that's CMake. Curses. So, and then if you add all these other stuff up, there's a lot of people are always upset about build systems. But, so I'm gonna be generous with myself and give it a B on this, because maybe some of you are too young to remember how horrible it actually was before there was CMake. Writing makefiles.in and then trying to link like big projects together. The whole reason CMake was created, it was pretty bad, and it was hard, and you had to really understand how things worked. You had to understand how your linker worked and what your command line was for it, because nothing really encapsulated that really well, especially in a cross-platform way. Like, how many people here know how to create a WASM library with the WASM and scripting compiler? Yeah, like 2. How many people might want to use that? Yeah, a lot more people. So CMake provides that, and it does make things more simple. There's obviously more work to do. Optionally provide a user interface to manage the build system. So we had, optionally you can run CMake on the command line. You can run CCMake, which is a curses-based terminal interface, the cute GUI. But then also many IDEs and editors provide GUIs for CMake now. CLion has same kind of cache editor, Visual Studio Code. So I think we could give ourselves an A+ on that, that we've really provided a user interface into configuring your CMake project. All right, creating an extensible framework. I'll be the first one to admit that the CMake language is no one's favorite part of CMake. People have done some crazy stuff with it, like create a ray tracer. This actually works. I've run it myself. So I'm going to give us a B. It was extensible. It just may not be everybody's favorite thing. And it is extensible, right? It has custom commands, and you can do a lot of stuff in your build. You can do really crazy things. So it allows like access to the whole process of the build.
I would say that's a bug, not a feature.
I would agree, and that's why I'm giving myself a B there. A self-sustaining community of software users and developers. I think this one's gone really well. There's almost 1,500 contributors to the CMake project. Craig Scott's written a much better book than we did about it. And I was sitting in this is a picture I took at the Microsoft Visual Studio, what's new in Visual Studio Code, and probably half of that talk was like cool stuff you could do with CMake and Visual Studio Code. So the community's really growing. And even this was 20th birthday. It was a shout out from the Visual Studio team to the CMake team, saying happy birthday to CMake. So I'd give us an A here. So CMake 4. What do you think CMake 4 is going to be? I think it's really going to be more about implementing and defining formats that other applications can use, and making CMake more accessible to the general ecosystem. CPS, which I'll talk about a little bit, it's a JSON file, and it'll be available to IDEs, package managers, and other tools to consume. With modules, we've worked with the standard committee to create the P1689 scanner format, and then there's P3286, which is module metadata format, which is used for the implementation of import std, and will eventually be used by CPS. So remember this, there's some documentation. The best way to learn it is copy it. So there's lots of bad CMake code out there. So originally when someone wanted to go from, say, make system to CMake, you would just add your CMake list file, and it could sit right next to your configure system. Your your two build systems could sit in the same source tree and they wouldn't clobber each other. But now we've got the problem where maybe you want to go from CMake 1-ish to 2-ish to modern CMake. You can't have two CMake lists in the same tree. So we added the feature to have an alternate file name for CMake lists, because you can't have both. But you could have like CMake update.txt and CMake list.txt. This is implemented with CMake -- project file, and you give the project file name. Works with add subdirectory. It will fall back to CMake lists if you haven't added it like all the way through your tree. So it's intended to be temporary. It's always going to emit a warning. It's not like, hey, I don't like the name of CMake list.txt. For my project, you're going to always start it this way. That's not what it's intended for. It's to help you move from one version of CMake to a new version of CMake. All right, what's cooking in CMake? So the best place to look for this is the experimental documentation. You can go to CMake's master and look it up on our GitLab. And this has the experimental features that are sitting in CMake right now. And there are, let's see, 1, 2, 3, 4, 5, 6, 7 of them. The first 3 are all related to CPS, the ability to export package dependencies, and to have export find package dependencies working, export the common package specification information, and find import CPS files. Import std is one of them. Build database support, the JSON file that will be useful for building modules. And then instrumentation, which I'll get to what that is. So CPS, how many people have heard of CPS? Okay, good, most people. So this is a common package specification. I've done some talks on it. There's been a lot of stuff about it. It was actually started in 2016 by Matthew Wolke at Kitware. There was a WD21 paper in 2018. 2022, there was a talk at C++ Now by Brett and Daniel. 2022 CppCon hallway track with Conan and VC Packaged and others. In 2023, there were 3 talks at CppCon. 2024, working on exporting CPS and CMake, that's there now. I did a C++ Now talk this year. And the idea is to have actually codify what a library is. So you would think after 25, 50 years of having binary libraries on systems, we would have defined what they actually are, but not really. Basically, if you have foo.so, how do you use that? What you need to know, include flags, what compiler flags are compatible with using it, what -d flags go with it. There's a whole bunch of extra information that you need to know to consume a library. And the way CMake solved that was to export CMake list files, these CMake config files in the CMake language, which was great for CMake, and it really moved modern CMake forward, but wasn't great for the rest of the ecosystem. The poor Conan guys, they got to read CMake list files and try to figure out stuff, or other package managers. Really, the idea here is to move that to a portable format, have it in JSON, and this is being developed in the open source. It allows for multiple configurations for a given package, multiple components, flexible version compatibility, relocatable by default. Transitive dependencies should just work. And here's sort of a sample CPS file. So in the old way, you'd have install, export, example targets, and then I'd install the .cmake files for the example. In the new way, I just have a single install that installs the package information for example, and I export those targets. And what's really cool is it's the same fine package. So we're trying to be as compatible as possible and to create a system that could be easily plugged in, and hopefully in the next year, 2 years, 3 years, this becomes the thing that everybody does. And this is how we communicate build system. And I think this is, as Brett and I said at our talk here a few years ago, this is a first step towards package management for C++, defining this standard and this way of specifying what a library is and what a package is. CPS can integrate well with package managers. There's been some experimental work in Conan and SPAC, and it's very promising. I've played around with it myself. Both, the package managers can consume the CPS files that CMake generates, but they can also create CPS files. So they've got some other build tool that isn't CMake and it didn't have a CMake configure file. Well, now they can create a CPS file for that and CMake can consume it. So it allows for this basically communication mechanism between the package managers and the build system. And then more build systems can adopt it because they don't have to learn how to parse CMake, which would be impossible for them to do. So if you're interested in CPS, please help contribute. There's reference docs. There's a project on Slack on the CppLang, slack.com. There's a hashtag ecosystem evolution. There's a mailing list. We get together like once a month. So if you're really interested in what's going on in CPS, I encourage you to join this community. The other big thing in CMake 4 is module support for C++. We've got C++ 20 named modules, and we're working on getting import stood out of experimental as we speak. It's getting there. There's some issues with the compilers. So a little, why do build systems care about modules and what grief does it cause them? I apologize if you've already seen this, but it's good to go over for people that aren't completely familiar. So with C++ modules, so I've got here A, which consumes B, B exports module, and then I go ahead and I try to compile A, and I get an error. Well, this is new. In C++, I can compile any C++ file without getting an error. It doesn't matter what order I build them in. It's embarrassingly parallel. I can build them all in any order I want. Well, not with modules, because as you can see, if I build B first, and then I build A, there's no error. And this because as a side effect of building A and B, it produces a built module interface, a BMI file. On Microsoft, it's called a .ifc file. And then you can see here that it's created those. And then, so now I've got a conundrum, right? Because if I want to build module files, I have to know who produces what modules and who consumes what modules. So how do I do that? Right? I've got to compile the C++ code to find that out. But wait, I need to compile the C++ code before I can figure out what order to compile the C++ code. How's that going to work? We had some experience with this in CMake. We did it with Fortran modules. The solution there was to add a simple Fortran parser into CMake. So obviously, we're just going to add a simple C++ parser into CMake. Maybe with reflection, you could. No. Yeah, so we obviously don't want to do that. That would be bad. Working with the standards committee, P1689 is a format for describing the dependency of source files. This was created and implemented now by the major compiler vendors. So now we can ask the compiler to parse the file and give us this information. And then CMake's got this process that it does where it essentially scans the files, each file, and pulls out the dependency information by querying the C++ compiler. And then it collates them into, for each target, and then it knows, it gets the full dependency info, and then it can insert that into the build graph for something like Ninja, which we had to actually modify Ninja. We actually had modified Ninja. a long time ago for Fortran, but they were not very interested in upstreaming that because they didn't care about Fortran. But when they heard they needed it for C++, it finally got merged, and the ability to do this is now in Ninja. So in CMake, this would look something like this. You'd just create a target, and then you'd add target sources using file sets. That's probably a CMake 4 is going to be the CMake of file sets. Everything shall be done with file sets eventually. And then you can install them and specify a module directory if you need to. Import stood. We're almost there. There's some rough edges, like sometimes Clang can't tell us where its module JSON file lives. So we're trying to figure out a way to work around that. But essentially, you could say import stood instead of pound includes, and we should get faster builds. Never worry about include what you use again, because you just say import stood. What this looks like in CMake, it has to be C++ standard 23 or greater. And then you can either set the CMake CXX module stood to 1, which will initialize all the target properties in that project to have that on, or you can set it explicitly for each target. And then when you actually compile something, you can see that there's a hidden target here that CMake manufactures that has the, we need to compile something that's got the information about how to use import stood. Okay, enough. So that's modules. There's also CMake instrumentation, which allows you to inspect at build time. So I showed you before that you could do performance testing of CMake, which got the configure and the generate phase. But remember, CMake is a build generator. So once it's done running, it's done configure, it's done generate, there's an Ninja file sitting there. You run Ninja in the build, how do you get information on that build? Well, with CMake instrumentation, CMake can collect data about each step of the build process. Tests, build, install time, and provide insight into performance of your build, even across users and different machines if you wanted. And it can generate a Google Trace event files for visualizing the data and analyzing parallels and bottlenecks. And that's in 4.2 or greater. So the way this works is that with instrumentation enabled, JSON files get spit out in these little fragment files based on different event types, and you can ask it which ones you want. So configure, generate, compile, link, custom commands, install, or test. Each snippet contains data such as time start, duration, role, output sizes, CPU load before and after, host memory usage before and after. So you get these, here was the command that was run, here's what it was doing, here were its outputs, here's the output size. So lots of really interesting information here. And then at user-defined intervals, CMake can automatically collate and generate snippet files, collate all the generated snippet files and create one big index file. So for example, after a build, after every configure or when triggered manually with ctest collect instrumentation. And then you can have custom callback scripts that are run when that build file is done. So you can get, basically you get past this hook. So to enable it, you call CMake instrumentation. You give an API version, the data version, some options. Alternatively, you can put a similar JSON file in the CMake .cmake config file. You can set environment variables. ctest use instrumentation to 1. Will enable instrumentation with a built-in callback to send stuff to C-. All right, the next thing that's almost in the kitchen. I kind of lied, you can see what's cooking by going to the experimental phase. But this one's actually just sitting in a a merge request, but we're adding SBOM support into CMake to generate SPDX files. So inside CMake, you can enable this by asking for install to do SBOM application targets, or alternatively, you can just do CMake -d install SBOM formats equals SPDX. That's the one we have implemented now. We'll probably add other ones later. But you could imagine doing this to a project, that you didn't want to change your CMake list files, but you still wanted an SBOM. And a package manager might use this to generate SBOM data, as opposed to having to go in and actually edit the CMake list file. And then you get your nice SPDX output that shows the SBOM information. All right, this is a cool one. There's actually, for the first time in like 10 years, I guess it kind of fits in the epics of CMake. And it's been a long time coming, so I think the original pull request for it was almost like 10 years ago.
12 years and 5 attempts.
Edward Verunken, I apologize if I'm pronouncing his name wrong. I've never met him in person, but he did the Herculean effort, along with some help with Vito, getting him across the finish line. He remarked that CMake has an incredibly wide set of things it actually does, and tests, right? So he was amazed once at the breadth of things he had to implement, and then also he couldn't get away with not implementing parts of it because it got caught. And even then, some stuff slipped through as we started testing it. So, but this is really cool. It's a new thing, kind of like Ninja. And here in it, but its claim to fame is it does distributed builds really fast. I mean, it natively on Windows, Linux, and Mac, and I was able to just sort of play around with it here. So this is, I'm actually cheating here. It's actually running local on this laptop. I didn't grab a screen thing before when I had it, but I did that with like my Mac and my old Mac, and was able to, like in 5 minutes, set up a distributed build. So it's incredibly easy to use. And then it also has built-in caching of object files. So in this case, I've already had a build with cache on, and I did a clean, and now I do another build, and this is building CMake itself. And you can see I always, my build tree name is always called MySpace builds, because you always need to test spaces in the paths. Always gets people. But you can see here, yeah, it completely built CMake in like 9 seconds, basically using all the cached files. So I did some performance testing. And actually, since I did this, we found an issue in FastBuild and made it even a little bit faster. And it's new, so it does tend to take longer with the configure step. We'll have to, the idea was to get it feature complete, get it in there, and it hasn't been optimized at all. Like the rest of CMake's been very heavily optimized. But basically, the first full build, it's slightly slower than a Ninja build. And actually, I think this is even a little better now with the one fix that we found. The distributed build is a little faster. Turning caching on can make it a little faster. Rebuild after clean, you can see the distributed build drop things down. That was just 2 machines, an old Mac and a relatively new Mac. And then basically a cache rebuild, with what I just showed you. So it's really neat. I encourage you to give it a try. I warned the FastBuild developer that he was going to get inundated when this got announced, and we'll put out a blog. But I expect him to get inundated. But it's kind of cool that we got something new here. All right, going back to the documentation, let's just come back to Hannes. There's a new modern tutorial on the way. Vito tells me it's moments away from being ready.
It could merge tomorrow.
There you go. But yeah, the idea here is to update the documentation and make sure the tutorial represents modern CMake. CMake can now export serif with its warnings and errors. And again, this hits on the theme of CMake interopting with other packages and other tools. So here's the rest of this stuff is just stuff I'd like to see. Bill's dreaming, but I think let's move on and see what cool things I'd like to see. CMake linting. Wouldn't it be great if we had a CMake linter? So we have this old project here where we're using horrible things like global include directories, add definitions. Wouldn't it be cool if we could run something that said, warning, you should use 3.15, it detected old style includes, add definitions found, don't use that. We'll get something like this working in the next year or two. Well, we'll see. I think we need this. How many people think we need this? Yeah, everybody, see? Now, if you all paid your $100, we'd have it already. All right, another thing I've learned is that CMake is not a package manager. And that projects and complexity have grown over time. This is a cool slide that Todd Gamlin, the creator of the SPAC package manager, created showing HPC simulation rely on icebergs of dependency libraries. Something like 77 packages with 168 dependency edges. This is huge and massive, and you're not going to do this with an external project or fetch content. It's not going to scale. It's not going to work. You need some sort of package manager if you want to handle stuff like this. I like to think that maybe CMake was somewhat responsible for this explosion in packages and interdependencies because it allowed people to build this stuff and link them together, however they did. But here we are, and CMake isn't the right tool for this. You need a package manager for it. So the current CMake workflow, you edit your source code in the source tree, you run CMake. It generates a build system of your choice. Maybe it's FastBuild, maybe it's Ninja, maybe it's Visual Studio. And then you kind of go from there. Now, this is just totally me, and it may never happen, but I think it would be cool if we had a new step called CMake provision. And this would run almost like CMake can run different backends like Ninja and Visual Studio and FastBuild. It could run maybe your package manager of choice that you've configured for, SPAC, Conan, VC package, et cetera, and pull all your dependencies that maybe are specified in some sort of TOML file or JSON file that sits in your CMake tree, and then CMake runs its normal way and does its fine package, but except that the whole environment's been already set up by a package manager. But I still get to use my CMake Ninja workflow that people know and love, except I would do CMake provision, then CMake, configure, generate, and then run my build tool. I think this, and then people have tried to do things like this, but then, through external project or something like that, but then you get the configure step is doing too much. And then if you get errors, people don't even know what, was it the package manager's fault? Was it something in my thing that didn't build? This clearly delineates the steps. So that's one thing that I want to figure this out. If you've got ideas, come join the community. I think we should all be able to figure out how to make something like this work. Another really interesting thing that I've been talking with the SPAC developers about is this concept of SPAC develop plus CMake. And what that means, so essentially in this future I envision, you've got a well-defined CMake file plus a package manager, we'll call it SPAC. And then I'm able to develop libraries. So let's look at a simple example. Say I've got, my thing that's got, A through F libraries. and I'm a developer. I don't really care about anything but A, B, and C. So I'm able to say to my package manager, hey, I want to develop A, B, and C. And it sets them up with like my normal source trees, get checkout of A, B, and C, and a build tree that's, next to it. And I can do my CMake, build, configure. And the other things, hey, package managers, get them from binary cache or build them if you have to, and they can be built and installed somewhere. And I can do my edit, run, debug, and it's doing that with like a no install build, right? And what I mean by that is it's actually just running out of the source tree so that when I get errors, it doesn't go like over to some install tree and get a copy of the file. I want to be working in the code, and I need it to be building directly for those packages there. But then, as I'm going along, I realize that, there's an issue in F, so I want to add that to my develop system. So I go into my package manager thing and I say, hey, I want to develop F too, and it throws away, the F that it got from the, either binary cache or it built, and it pulls it into my source area and does, a no install build, and then I can edit, run, compile A, B, C, and F. And then, eventually like those A, B, and F kind of stabilize, and I want to only work on C. So I can say, I want to focus down on C, and I want the other things can be there, and it'll be a little faster turnaround because now I've got less stuff to work on. So that's my supervision. I think something like this would be really great for C++. How many people would love something like this? Yeah, lots of hands. So you should all complain to the DOE for not funding the SBIR for this. So yeah, basically the errors of CMake. CMake 1, the primordial flag soup, world domination. CMake 3, I hope you like target star commands. And CMake 4, I think, is going to be all about interop and standardization. So I hope you like JSON. And thanks to all of you for helping achieve the goal of developing an open source cross-platform build tool. Without users, there is no project. You have to have users to be useful. And we've got lots of users now, and all the people who have contributed to CMake, I really want to thank all of them. So thank you, and come join the community. The way we do things in CMake, you say you've got a new feature. This is really important. Let me get this message out. Like Brad King will thank me for this. If you want to add a new feature to CMake, create an issue and describe it first. Like, hey, I've got this great idea and I'm going to implement this. And then post it to the discourse and get a discussion going on about it. Don't go off. Remember the cathedral and the bazaar? How many people read that book? Yeah, don't go off and try to create a cathedral. Work in the bazaar and actually, work on it so you don't like spend 6 months of your life developing something and then only to find out that, Craig Scott Vito and Brad just vetoed you and it can't get into CMake. Whereas if you had talked to them earlier, you could probably have worked it out and come up with a better solution in the first place. Join our discourse list. Go on Slack, CppLang, #CMake, #CMake ecosystem evolution. Or hey, if you don't want to be bothered with all this at all and you just want to hire Kitware to solve your problems, go to www.kitware.com. And with that, I will end the talk and open up for questions.
Hello, thanks for the talk. I had questions about the SBOM implementation, or the SBOM support. Is that something that's pulled from external package managers and the internals of CMake for a project? Like your own applications that you're building and like talking to package managers to like get your external dependencies and to understand more about how they're built to pull that into like an SBOM format.
Or you can answer it over there.
Okay, excellent. Okay. Hi, I'm Vito. To the degree that the package manager will tell us things, we will incorporate them into the SBOM. Some package managers tell us a lot of things. Some package managers don't tell us anything at all. We have some polyfills for things. I'll open with this. The SBOM package management information is built on top of CPS. We are extremely opposed to putting more things in CMake language. I don't think I have to sell anyone on the idea that putting more information in CMake language is maybe not a great idea. So package managers that speak CPS, we have good ability to import those into the SBOM. For things like, for package managers that aren't there yet, we are working on like polyfills and like Python scripts that you can run on your install tree to generate CPS. And that's the status. If you have CPS, we will give you that in the SBOM. If you don't have CPS, then we're sort of like, you didn't tell us anything, so we can't put it in.
Thanks.
Thanks, Vito.
I'm one of those weird people that actually likes CMake and the language therein. But one of my biggest issues with CMake is when I want to spin up just a really quick library to test some idea. I need a copy of an existing template CMake file that I'd already built years ago, and just modify a bunch of files, a bunch of like names in there. I think it would be very handy to a lot of other people to have something similar to like that, but my workflow for myself is very unique. Do you know of any tool that would allow like a templating of a starting CMake list that will get you a very basic tree that you can say CMake build this?
I don't know of something like that, although LLMs are probably getting closer and closer to being able to do that for you. So I would, in this day and age, I would start there, and it'll probably get you 95% of the way there.
Thank you.
Hi, a common issue that people seem to be having with CMake is that my distro has only this old version available, and they cannot get to use the new features. And when I look at other tools and languages, well, I see Rust as RustUp, NPM as MVN, Bazel as Basilisk, and a lot of other tools that is able to provide you the newest version of CMake automatically, install it with the project, so you can always use the latest and greatest. Has there anyone brought up this issue to you, or like the idea of a tool that would provision a new version of CMake for your current system so that you can always have something up to date and you don't have to be held back by those old distributions that will never be updated unless some big corporate entity decides to drop it, which might take many, many years.
I mean, the CMake itself is, we've got binaries on the CMake webpage. You can download them, you can run them, not even being root.
But that's not automatic.
Oh, yeah.
Yes. I've asked Brad King this question. I can just answer this.
You go ahead.
So I've asked Brad King himself this question a couple times. The basic idea is it's about empathy to developers who have different use cases than your own, right? And this is always what CMake's problem is, that we have, you say, okay, my environment would be really useful if this worked. We are generally hesitant to add features that don't work in everywhere, that don't work on the AIX machine that is disconnected from the internet that sits in a office somewhere, right? So if we start building infrastructure into CMake that only works on the latest MacBook that has an internet connection and stuff like this, and obviously this is much more limited feature than that, we don't like that. We would like to see that exist outside of the CMake binary itself. Install it with PyPy, like build your build infrastructure, have Conan pull it down, have your, whatever is orchestrating your build, we would like to see it there rather than built into the CMake binary itself.
Of course, and I've never said that you should be in CMake. It's usually a side project that helps you facilitate spawning CMake and at the right version for the project, or the latest one if you want it. I think that would be really valuable.
Yeah, I think the Python approach is the best. And that's actually one of the most frequent download spots from CMake is the Python.
Who's going on for that? Who's going?
Or spec.
Thanks for the talk. It was very interesting. I found it very entertaining. And actually, so I don't have a question. I just wanted to mention the example that you gave where you were like, oh, I'm going to make my build directory called my build with a space in the middle of it. Like, what could possibly go wrong? I decided to try that with my build, just like what could happen. it immediately explodes. So, so I have more work to do. Thank you very much. But yeah, like it doesn't even build anything; it dies instantly. So,
Yeah, that's common for when people contribute stuff to CMake, and then they try to do the merge request because our CI stuff usually does space, and they're like,
yeah,
it's failing on this platform. It's like, it's failing because do you have a space in the path? Oh,
yeah,
I never tried that.
Thank you. Yeah.
Hey, so I think one thing that I'm a bit like sometimes I'm confused with CMake is like everything is string, so like list a string, number a string, and like everything is string, and
It
so
strings all the way down.
yeah. So do you think it's like a good design decision? Like if you have a time machine bad, like do you think CMake would benefit if we have a better better type system, a true type system?
How much is it going to cost to make CMake language better? What was that slide?
Yeah, it'd be a lot of work at this point. So yeah, probably could have done better. I'll move that grade to a C. All right, I think we're out of time here. Really appreciate everyone coming, and thanks for listening.